Myself, Rajendra Eskarale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about rules for filling of molecular orbitals. This is only for NEET and JEE. But this is also important for state board and CBSE syllabus and also in MST CET. Now, the filling of electrons in the molecular orbital takes place according to following rules. Now here, in order to write the electronic configuration, now while writing the electronic configuration of any atom, the filling of electrons in the atomic orbital can be takes place according to the Aufbau Principle, Hund's rule, Aufbau Principle, Pauli's Exclusion Principle and Hund's rule. Now same rules are applied while filling the electrons in the molecular orbital. Now first here write down Aufbau Principle. Now here the statement of Aufbau Principle is that an electron enter the molecular orbital of lowest energy first and subsequent electrons are fed in the increasing order of energies in various molecular orbitals in the ground state of molecule. Now our second, Pauli's exclusion principle. Here, no two electrons in molecule can have same set of all the four quantum numbers. Or molecular orbitals can have at least two electrons provided their spin quantum numbers are different. Now third, Hund's rule of maximum multiplicity now we are pairing of electrons in the molecular orbitals does not take place until all the molecular orbitals are singly occupied. Moreover, the singly occupied molecular orbital contain electron with parallel electron speed. Now this is regarding about Aufbau principle, Pauli exclusion principle, and Hund's rule of maximum multiplicity. These three principles are very important while filling the electrons in molecular orbital in case of molecule. That means while writing the electronic configuration of any molecule, and this is same as that of electronic configuration of atom. These are given detail in the electronic configuration. That topic was given in the unit structure of atom. Now we have write down next topic, electronic configuration and molecular behavior. Electronic means electron and configuration means arrangement. That means arrangement of electrons in the various molecular orbital in the increasing order of their energy is called as electronic configuration. That means here distribution of electrons in the various molecular orbitals in the increasing order of their energies. That means here starting with molecular orbital of least energy. Now here, what are the information about the molecule provided by the electronic configuration? These are given below. That means here the various informations provided by the electronic configurations are: number one, it represents the number of electrons in bonding that means NB and anti-bonding that is Na. Molecular orbitals. Number of electrons in bonding molecular orbital are represented by Nb, and number of electrons in anti-bonding molecular orbital are represented by Na. Second, stability of the molecule. That means here the electrons in bonding molecular orbital increase the stability of the molecule in the molecule and the electrons in antibonding molecular orbitals decrease the stability in the molecule. Now here, case A. If MB is greater than NA, that means here number of electrons in bonding molecular orbital are greater than the number of electrons in anti-bonding molecular orbitals. That means here more bonding molecular orbitals are occupied that means here the bonding influence is stronger and hence the molecule is stable. Keep in mind, if Nb is greater than Na, that means number of electrons in bonding molecular orbital are greater than number of electrons in anti-bonding molecular orbital, then the molecule is stable. Case B, if Nb is less than Na, that means number of electrons in bonding molecular orbital are less than the number of electrons in anti-bonding molecular orbital. Here more anti-bonding molecular orbitals are occupied that means here the anti-bonding influence is stronger and hence the molecule is unstable. That means here also keep in mind, if the number of electrons in bonding molecular orbital are less than the number of electrons in anti-bonding molecular orbital, then the molecule is unstable. Third, if Nb equal to Na, that means here number of electrons in bonding molecular orbital is equal to the number of electrons in anti-bonding molecular orbital. That means here equal number of bonding and anti-bonding molecular orbitals occupied. That means here antibonding influence is slightly stronger than bonding influence. Hence, the molecule is unstable. That means here also keep in mind, if Nb is equal to Na, that means number of electrons in bonding molecular orbital equal to the number of electrons in anti-bonding molecular orbital, then the molecule is unstable. Now here write down third information. It represents the bond order Now, what is the definition of bond order? Half of the difference between the number of electrons in the bonding, that means Nd, and anti-bonding, that is Na, molecular orbitals. That means here bond order equal to 1/2 Nb minus Na, where Na and Nb are the number of electrons in anti-bonding and bonding molecular orbitals respectively. That means here write down case A here. If bond order is positive, ultimately bond order is positive means NB is greater than NA. Here the molecule is, hence the molecule is stable. Second, that means here write down number 8, stability of molecule, and then write down case 1. Now here we are write down informations again. Now the various informations provided by the bond order are. Now here number 8, stability of the molecule, and here write down case 1, if bond order is positive, that means here NB greater than NA, hence the molecule is stable. Case 2, if bond order is negative, that means NB less than NA. Here, hence molecule is unstable, and case third, if bond order is 0, that means NB equal to Na, hence the molecule is unstable. That means this is same as that of the number of electrons in conclusion drawn from the number of electrons in bonding and anti-bonding molecular orbital. That means both number of electrons in bonding and anti-bonding molecular orbital as well as bond order provide us the stability of the molecule, whether it is stable or unstable. Now second, number of covalent bonds. Now here bond order is equal to the number of covalent bonds between the atoms in the molecule. Third, bond dissociation energy. Which is also called as bond dissociation enthalpy. That means here bond dissociation energy is directly proportional to the bond order of the molecule. That means mathematically here bond dissociation energy is directly proportional to the bond order. Now here greater the bond order, greater is the bond dissociation energy. Now second, third, bond length. That means your bond length is inversely proportional to the bond order of the molecule. That means here BL is inversely proportional to the BO. Greater is the bond order smaller will be the bond length. Now here, keep in mind BDE is directly proportional to the BO. Bond length is inversely proportional to the BO. That is, what is the relationship between BDE and BL? BDE is also inversely proportional to the BL. Now, these three relations are very important while applying the molecular orbital theory to the various molecules. Now, then fourth, and these are the four information provided by the bond order. Number one is stability of the molecule. Number two is number of covalent bond in between the atoms in the molecule. Number three, bond dissociation energy. And number four, bond length. Now then, fourth information, magnetic behavior. That means whether the given molecule is paramagnetic or magnetic, that can be identified after drawing the molecular orbital diagram for various molecules. If in the molecular orbital diagram some electrons are unpaired, then the given molecule is paramagnetic, and if suppose all the electrons are paired, then the given molecule is diamagnetic. That means here write down case 1, if all the electrons in a molecule are paired, then the molecule is diamagnetic, that is repelled by the magnetic field. If some of the electrons in a molecule are unpaired, then the molecule is paramagnetic. That is attracted by the magnetic field. Now this is regarding about rules for filling molecular orbital and the electronic configuration and molecular behavior. Now keep in mind the most important rule while drawing the molecular orbital diagram, that are Aufbau Principle, Pauli Exclusion Principle and Hund's rule of maximum multiplicity and various information provided by the MO diagram, and remaining part of this unit will be discussed in the next lecture.